Yesterday we talked about perpendicular bisectors. We're still in section 1 of chapter 6. Today we're going to have that second note card. So you might want to take out a second note card today to make a flashcard and write on this one angle bisectors, because angle bisectors are different from perpendicular bisectors. A perpendicular bisector bisects a segment. An angle bisector bisects an angle. Just like to give you a minute to let that sink in. Perpendicular bisectors do not bisect perpendiculars. Perpendicular bisectors bisect segments. Angle bisectors bisect angles. Now, any point on a perpendicular bisector was equidistant or equidistant from the end points of the segment being bisected. Any point on an angle bisector, if AD here is my angle bisector, any point on that angle bisector is equidistant from the sides of the angle. So those two segments, DB and DC, which, by the way, to measure the distance from a point to a side, we have to give the right angle distance, and the right angle has to be with the side, not with the bisector. Those two segments have to be congruent. Conversely, the same thing is true. Any point that is equidistant from the sides of the angle must be on the angle bisector. So any point equidistant from the sides of the angle is on the angle bisector. So great stuff. Great stuff. Let's see how we use it. All right, find the measure of angle GFJ. Well, we got two choices here, basically. We have the choice of, well, it's either going to be 42 degrees, just like the other angle, or we're not going to have enough information to figure this out. But I do note that GJ is 7, that HJ is 7. They are both right angles, so they are both, that is the distance from the side to the point J, which means that FJ must be the angle bisector. If that's the case, 42 degrees for GFJ, we're good to go. GFH, if we need it, is 84. Here we're given that QS is the bisector, so if we're given that fact, which we should have noted on here, but it isn't, so I'll write that down. QS, that's supposed to be an arrow, bisects angle PQR. So I'll be given that. Find RS. Well, what do we know? Since it's the angle bisector, actually we are given it kind of here. I didn't notice the little marks, so the marks do give it to us. I'd rather they write it down, though. Getting back to the problem, I know that PS has to be congruent to SR. So 5x has to equal 6x minus 5. Subtract the 6x from each side. Now I know that's a little not protocol because it's going to give me a negative 1x, but otherwise I'd do two steps of addition. Subtraction, negative 1x equals negative 5, so x is 5. That's great, x is 5. Am I done? Nope, I want to find RS. So I have to substitute back in. RS is 6 times, so RS is 6 times x minus 5, 30 minus 5, which is 25. And I could confirm that by finding PS, which better be the same. 5 times 5 is 25. Boom, we're done. Good to go. So everything's working exactly the way it should. Not a problem at all. Again, pretty straightforward. BD bisects angle ABC. DC is 6.9. How long is DA going to be? Pretty obviously going to be congruent at 6.9. BD bisects angle ABC. AD is 3z plus 7. CD is 2z plus 11. Remember this from yesterday. It's almost the same. Again, we set it up. 3z plus 7 equals 2z plus 11. We do our algebra. I'm sorry, minus 7. And I get z equals 4. positive 4 squared, excuse me. It's not negative, it's positive 4. So z equals 4. That's not the question, though. The question is find CD. CD equals 2 times 4 plus 11. 8 plus 11 equals 19. And we can check to see if that's the same as AD. 3 times 4 is 12. 12 plus 7 is 19 as well. Finally, find the measure of angle ABC, which is the outer angle when AD is 3.2 and CD is 3.2. Aha, so if both these are 3.2, that means this is the bisector. And if DBC is 39, I want the whole angle. That's going to be double 39 or 78 degrees. Only thing you need to really be careful of there is to make sure that you answer for the correct angle. You don't answer ABD. You find the measure of angle ABC, not ABD. A soccer goalie's position relative to the ball and goalpost forms congruent angles, as shown. Will the goalie have to move farther to his left or to his right to block a shot that's coming in? Which way will he have to move? If the shot is going to be on net, which way will he have to move farther, left or right? Again, he is on the angle bisector. If he's on the angle bisector, it means he is equidistant from both sides, that these two are congruent. So he has to move the same distance left or right to block a shot that would be on frame. So as far as positioning goes, if you're playing keep in a situation like that, you want to be on that angle bisector to make sure you can move equally to the left and right sides of the goal to block the shot. That's why the goalkeeper stands in that position. Now it gets more interesting. Finding the equation of a perpendicular bisector. Now, it's given to us here, but I'm going to work us through the steps of finding that equation. I have segment PQ. I know where the endpoints of P and Q are. I'm given them. P is negative 2, 3, and Q is 4, 1. I need the equation of the perpendicular bisector. This really puts us to the test, because we have to understand several things. We need to understand how to find the equation of a line, how to find the midpoint of a segment, how to find the slope of a line, how to find the slope of a perpendicular line. All these things that we've covered in previous chapters. This is a great review for our midterm exam problem like this, because it makes us use all these skills. So the first thing we need to do, if it's going to be a perpendicular bisector, remember, to find the equation of a line, we need to know, 1, a point on the line, and 2, the slope of the line. This line we're talking about here is the red line. I need to know a point on that line. I need to know the slope of that line in order to find the equation of that line. Well, the point on the line is going to be the midpoint of PQ here. The slope of the line is going to be perpendicular to the slope of PQ. Once we do that, then we plug into our equation and solve. So I need to find the midpoint of PQ and the slope of PQ. So let's start out with that. The midpoint of PQ again, P is at negative 2, 3, and Q is at 4, 1. So the midpoint of PQ would be at negative 2 plus 4 over 2, 3 plus 1 over 2. So negative 2 plus 4 is 2, 2 over 2 is 1, 3 plus 1 is 4, 4 over 2 is 2. So the midpoint is at 1, 2. And we see that right here. Next thing, you need to know the slope of PQ. Slope is a different formula, y2 minus y1, so 1 minus 3 over x2 minus x1 for minus negative 2. That's negative 2 over 6, or negative 1/3. But I don't put that into my equation because I want a perpendicular line, so the perpendicular slope is going to be the reciprocal of the negative 1/3 and the opposite sign. So 3 over 1 positive, or 3. Now I have my point, I have my slope, I can write my equation. Using point slope form, y minus y1 equals mx minus x1. Y minus the y coordinate of my midpoint, 2, equals slope 3x minus the x coordinate of my midpoint, 1. I distribute. I combine terms. I get y equals 3x minus 1. And that is the equation of my perpendicular bisector. Sure enough, that's what's written on the screen as well when we started out. But you need to walk through that process. That is a long process. Give you a minute just to kind of think about that. That requires a lot of thought. And that requires some time. You're going to maybe need to spend some time reviewing that process. You might need to go back and watch the podcast from, I think, chapter 3 on writing the equations of lines and parallel lines and perpendicular lines. That's one of the beauties of the flipped classroom, is you're saying, you know what, I really forgot how to do that. You can go back and catch that lecture again. Now, I know going back and watching an old podcast is not really very exciting, but they're all named pretty descriptively, and all you got to do is go on my page and go into the go onto my channel, and you'll find that there are groups of pages there that go with chapter 3. So find that podcast and watch it again if you're having difficulty finding the equations of lines. Do I have enough information in number 7 to prove that QS is the bisector? SP is congruent to SR. Isn't that enough? No, it can't just be congruent. They also have to be perpendicular to the sides. Those are not right angles, so no. Okay, angle P and angle R are not right angles. Finally, write the equation of a perpendicular bisector to a segment with the given endpoints. So exactly what we just did before. Find the midpoint of this segment. So right back to where we were. The midpoint is at negative 1 plus 3 over 2, negative 5 plus negative 1 over 2. Remember, for midpoint, we add and divide by 2. Negative 1 plus 3 is 2. 2 over 2 is 1. Negative 5 plus negative 1 is negative 6. Negative 6 over 2 is negative 3. So there's my midpoint. The slope of the segment, okay, change in y, negative 1 minus negative 5, or negative 5 minus negative 1, I guess we can do it that way. Over change in x, negative 1 minus 3. Negative 5 plus positive 1 is negative 4. Over negative 4, the slope is 1. So the perpendicular slope would be negative 1 over 1, which is negative 1. And then we write our equation, y minus negative 3, so y plus 3 equals negative 1, x minus 1. So y plus 3 equals negative 1x plus 1, y equals negative 1x minus 2. That's the equation of the perpendicular bisector to that segment. Again, go back and review writing equations if you need to. By all means, that's why it's there. All right, that's a lot for today. We'll catch you in class.